In this lesson, we are going to look at equations involving number bases. Questions on number bases which involves variables usually lead to linear or quadratic equations. Example, given that 4m4 base 5 is given as 119, solve for the value of m. So this is an equation. 4m4 base 5 is equal to 119. So here we have to express both equations to base 10 before we can solve for the value of m. So this gives us 4m4 base 5 is equal to 119 base 10. Don't forget that any number without a base is considered in base 10. So first of all, we have to convert this to base 10. And what is the place value? We have ones, tens, hundreds. So we have to expand with the given base, which is 5. So we have 5 exponent 0 is 1, 5 exponent 1 is 5, 5 exponent 2 is 25, in that order. So this gives us 4 multiplied by 5 plus m multiplied by 5 plus 4 multiplied by 5 equal to 119. This is already in base 10, so we don't need to convert it. So this gives us 0, 1, 2 in terms of place values. 5 exponent 2 is 25 plus 5 exponent 1 is 5 plus 5 exponent 0 is 1, and this is given as 119. This gives us 4 multiplied by 25 is 100 plus m multiplied by 5 is 5m plus 4 multiplied by 1 is 4, and this is given as 119. This gives us 104 plus 5m is given as 119. Let's do rate grouping. So we have 5m is given as 119 minus 104. So this gives us 5m equal to 119 minus 104 is given as 15. So divide both sides by 5, and our m is given as 3. So therefore, our 434 in base 5 is given as 119 base 10. So actually, when we convert this back to base 10, we still have 119. 2. Let's solve for the value of y given 211 base y equal to 320 base 4. So first of all, the base is given as y, so we don't know the given base. So we have to first of all convert both sides of the equation back to base 10. So this gives us 2 multiplied by y. So we are expanding with the given base plus 1 multiplied by y plus 1 multiplied by y. And this is giving us equal to 3 multiplied by 4 plus 2 multiplied by 4 plus 0 multiplied by 4. In terms of place value, we have this is 0, 1, 2. So this is giving us y exponent 2 is y exponent 2. So we have 2 y exponent 2 plus y plus y exponent 0 is 1 multiplied by 1, and we have 1 equal to, so we have 0, 1, 2. So this is giving us 3 multiplied by 4 exponent 2 is 16 plus 2 multiplied by 4 exponent 1 is 1 plus 0 multiplied by 4 exponent 0 is 1. So this gives us 2y exponent 2 plus y plus 1 equal to 3 multiplied by 16 is giving us 48 plus 2 multiplied by 4 is giving us 8 plus 0 multiplied by 1 is 0. So this gives us 2y squared plus y plus 1 equal to 48 plus 8 plus 0 is giving us 56. In terms of regrouping, we have 2y squared plus y plus 1 minus 56 equal to 0. So this is giving us 2y squared plus y minus 55 equal to 0. So we have 2y squared minus plus y minus 55 equal to 0. Given the general quadratic equation, which is ax squared plus bx plus c equal to 0, to factorize this, we take the product of the coefficient of x squared and c, which is ac. We take both positive and negative factors of the product. That will give us, when we add, we are getting the coefficient of b, but when we multiply, we are getting c. So this is giving us 2 multiplied by negative 55 is giving us negative 110. So the factors are 11 and negative 10. When we take the addition of 11 and negative 10, we are getting 1 here. The coefficient of y is 1. But when we multiply them, we are getting negative 55. So we have 2y squared plus 11y minus 10y minus 55 equal to 0. So this minus 11y minus 10y will give us y, and the product of 11 and negative 10 will give us 55. So we can have these groupings here in terms of factors. Here y is common, So we factor y out, leaving 2y plus 11. Negative 5 is common here. So when we factor negative 5 out, we are getting 2y minus 11. And this is equal to 0. And this is plus 11. So we can see that this is a repeated factor. So we have y minus 5 and then 2y plus 11 is given as 0. So therefore our y minus 5 equal to 0 and then 2y plus 11 equal to 0. So therefore our y is equal to 5 and y is equal to negative 11 on 2. But we don't have negative bases. So therefore our y is 5. So therefore our 211 base 5 is equal to 320 base 4. Here we are given if x base 4 is equal to 145 base 6, solve for x. Here we can note that the bases are, we have bases in both equations, but this is a number. Unlike the other equations, this one we cannot convert this straight to base 10. So this gives us x base 4 is equal to, let's convert this one to base 10. So we have 1 multiplied by 6 plus 4 multiplied by 6 plus 5 multiplied by 6. In terms of place values, we have 0, 1, 2. So this is given us 1 multiplied by 6 exponent 2 is 36 plus 6 exponent 1 is 6 plus 6 exponent 0 is 1. This is given us 36 plus 24 plus 5, and this is given us 65. So therefore x base 4 is given as 65 base 10. So now that we know that x base 4 is equal to 65 base 10, then let's convert 65 base 10 to base 4 and we'll get the value for x. So this gives us 65 and our given base is 4. 4 goes into 64, 4 goes into 65, 16 times remainder 1. 4 goes into 16, 4 remainder 0. 4 goes into 4, 1 remainder 0. And 4 goes into 1, 0 remainder 1. Reading from bottom top, we have 65 base 10 is given as 1001 base 4. Our 1001 base 4 is given as 145 in base 6.